different periods from the periodic table. The first thing you do when you look at the table is you try to think about labeling as much as possible. You've got 1, 2, 3, 4, 5, 6, 7, 0. These are the groups, so you could put group there. Second thing you could also do is label the different periods, which are 1, 2, 3, 4, 5, 6, and 7. One thing you could do is also show the charges on ions formed now that you have done ions. And if we think about the ions as you go from left to right, everything in group 1 forms +1 ions. The metals, group 2, 2 plus. Group 3, if we refer to aluminium, 3 plus. Chlorine and everything in group 7 forms -1 ions. Non-metals in group 6 form 2 minus ions. Non-metals in group 5 form 3 minus ions, which may be helpful. The other thing we could also draw is draw a line to separate metals from non-metals in the periodic table. It's a line which starts off above aluminium, it's a horizontal line, and then goes down like a set of stairs. So, and obviously you could do a little label thinking to the right, as in all these here, like non-metals, and to the left, metals. So if we look at our first question, configuration of 5 different elements, what can we work out? Firstly, we could write the electron configurations as, in shorthand, 2, 8, and then the outer shell 7. This one here is 2, then 1, 2, 3, 4, 5, 6, 2, 6. This one is 2, 8, 1, 2, 3, 4, 5, 6. This one is just 2, and this one here is 3. So if we were trying to identify them, we could add all the electrons together. So for example, this has 17 electrons here, and it's got 17 electrons and it's an atom. Then, and it also says they all represent atoms. The number of protons will be 17. And from our periodic table here, we can see it has a key. It tells us the atomic number or proton number is the bottom number. We find 17, and we can find this one here is chlorine. Second one, 2, 6, 8 protons. So we can look it up in the periodic table, find that's oxygen. Next one, 2, 8, 6. To speed it up, I know that the number of electrons in the outer shell here is equal to E minus in outer shell, which is equal to group number. So that's group 6. We also can see, if we look here, it's got 3 shells, first shell, second shell, third shell. That's got 3 shells, and the number of shells is equal to the period which the element is in. So we're looking for group 6, period 3. So we look for group 6, here we have group 6, period 3, we can find that one there is sulfur. This one here, 2 electrons in the outer shell, 1 shell, that is going to be helium, and this one here, 2 electrons in the first shell. I don't know why I just wrote 3 there, by the way, so I should have been 2, 1, sorry. 2, 1, 1, second period, group 1, second period, obviously checking on that side there, we can find that one is lithium. So now we can work out what the questions ask us. An alkaline metal, if we look at the elements which have been given, we've got chlorine, oxygen, sulfur, helium, and lithium. So the only one which is a metal is lithium. So we can say the one which is a metal is lithium, so that is E. Contains 8 protons. This has got 8 electrons, and as it's an atom, it'll have the same number of protons, so it'll have 8, so that's going to be B. Sulfur, I've identified it. So sulfur is obviously going to be C. Pull out a shell. If we did a little table saying max E minus for a shell, we could do first, second, third. Max electrons for first shell 2, second shell 8, third shell is happy with 8. That's supposed to be a start, by the way. So, which one has a full shell? That's going to be D. In group 7 of a periodic table, something which has 7 electrons in the outer shell, that's going to be A. And in period 1 of a periodic table, we've just said the number of shells which you use is equal to period. So this has only got 1 shell of electrons, so that's the only one found in period 1. We can also check on the periodic table. Helium is the only element in period 1 of the elements we have a choice of. So that is going to be D. And then in the same group as B, B is in group 6. What else is in group 6? The answer is going to be C. So C there. Now, if you get any of these wrong, I'm going to write down a comment I would like you to write down for each one to help you avoid making the same mistake in the future. So, if you got question 1 wrong, what I would like you to know, obviously we're at letter E, and you could say metals have 1, 2 or 3 E minus in outer shell in general. So that's maybe something you could write to help work out that and avoid that mistake in future. It contains 8 protons. You could say here, and this again, if you got this one wrong, this is what I would like to write. Number of protons equals number of electrons for an atom. If you got the next one wrong, let's change colour so maybe this makes it slightly clearer if you're making annotations. For sulfur, you could write some E minus, and you can say what it's equal to, where if we go 2 plus 8 plus 6 gives us 16 electrons. Then you could say as atom, this implies 16 protons. Then you could say use ET to look up. Pull out a shell. If you got this one wrong, you could describe or write the number of maximum electrons for each outer shell. So max 2E minus in first shell, 8 second, 8 third. It's not always 8, but anything you're ever asked to will always have a maximum of 8. Group 7 of a periodic table, if you got this one here wrong, then you could say group equals number E minus in outer shell. Period 1, if you got that one there wrong, what you could say is period equals number of electron shells. If you got this one here, you could write this comment here about groups, or you could say group equals, I suppose, number E minus in outer shell. So if you're not sure about what to do with this, firstly you could always write down the definition of what an isotope is. So atoms, an estimate of the same element. So explain what we mean by same element. So same number of protons, but different numbers of neutrons. Now again, if you got it wrong, I would like you to write that down. Then we can explain it for this particular example. And you say both isotopes contain 5 protons, which is what's the same. So we're making sure we're explaining using an example. Now boron, we know it's telling us if it's got 2 versions of boron. If it's got 10 here, this is talking about the mass number up here. This here, 11, is the mass number up here. And again, we've said for both, they have 5 protons. As for atoms, so you'll have the same number of electrons as they have protons. And the difference between these two numbers is equal to neutrons, because this is the mass number and it's equal to the number of protons plus the number of neutrons. So 5 taken away from 10 gives me 5. This one here has 6. And you could say boron 10 has 5 neutrons and boron 11 has 6 neutrons. What is meant by the term relative atomic mass? So it's relative to something, and if you think about what you're going to do in the next part where you work out the relative atomic mass, we try to work out a mean, or a simpler version of that idea of mean. In terms of chemists, we only tend to use mean rather than any other sort of average. So we talk about the average mass of atoms of an element. So we're trying to take into account all the different elements and we're trying to compare it to carbon-12. So average mass of atoms of an element. So we're taking into account all the different versions of that isotope. And then we say what it's relative to or compared to. 1/12 mass of a carbon-12 atom. Now, basically you don't necessarily need to worry about 1/12 mass of until you, or if you choose to do A level. So compared to a carbon-12 atom, this is because carbon exists as 2 versions. There's carbon-12, which is most of the carbon. There's also carbon-13 and carbon-14, so I had to choose something. And if you imagine that had a mass of 12, if we took a 12th of it, we would get one sort of unit of mass. The sample of boron contains 19.7% of boron-10 and 80.3 of boron-11. Calculate the relative atomic mass of boron, 2 decimal places. So what we need to do is, let's just assume we had 100 atoms. We have 19.7 of mass 10, so the total mass of that would be that. To that, we would want to add mass of 80.3 of boron-11. So 80.3 times 11. And we divide it by 100. So I mean, if you were doing it as an average of maths, you'd have 19.7, say, atoms of mass 10, and this would be 80.3 atoms of mass 11. So that's where you could sort of think about it. So in terms of just what you'd be doing if you were doing this, say, in a maths lesson. So if you do that, give your answer to 2 decimal places, you get 10.80. Now, you get basically 1 mark for this bit here, 1 mark for this bit here, and having that bit divided by 100, and then 1 mark for giving your answer to 2 decimal places. Now, lots of you didn't actually necessarily write down your calculation, so I would like you to write down your calculation. And the reason is because if you failed to write 10.80, you could still get marks for partial answers. So, question 3 shows the elements in the periodic table. It says, in sample B, there are 2 isotopes. One has a mass of 10, one has a mass of 11. What's going to be the key thing which they all share? So it told us the atomic number is 5. Again, if you looked at the periodic table, right at the very start, you would see that atomic number, it says, it has actually the word proton attached to it, like proton number. So these are the key numbers for it. So this is just telling us there are 2 different isotopes. What do they all have in common? 5 protons. Because again, if you thought about the 2 different versions, this is actually boron. We've just answered the question about boron. We've got 10, and we've got 11. Number of protons, number of electrons are both is equal to 5 and 5 and 5 and 5. The number of neutrons is equal to 10 minus 5, giving us 5. For this one, number of neutrons, 11 minus 5, giving me 6. Now, next bit, X has an atomic number of 18. What's the arrangement of electrons? If it's got 18 protons, it will have 18 electrons. 2 in the first shell is now full. Second shell can have a maximum of 8, second shell is now full. Third shell can have a maximum of 8, third shell is full. Here is a version of oxygen. If you got this wrong, I would like you to write the following annotation. That's equal to protons. This one here is equal to neutrons plus protons. This is also known as the mass number, and this here is equal or known as the atomic number. So it tells us the number of protons here, 8. If 17 is equal to mass of neutrons plus protons, we know there are 8 protons. 8 plus something gives us 17, and the number which fits in here is 9. So we'll have 9 neutrons, and then number of electrons in an atom, number of electrons is equal to number of protons. So that's 8, this will also be 8. Question number 5, we gave you 2 examples so you have an idea of what sort of type of value you're supposed to be putting. Protons and neutrons are 2 particles which give mass to an atom, and then the mass of an electron is 1 divided by 2000. Charges, neutrons, neutral, 0. Electrons, got positive particles, we're probably going to have negative particles, so electrons -1 position. Protons and neutrons are found in the nucleus, and electrons are found in electron shells. Now, it's got to be shells plural, because otherwise it might suggest that all the electrons are just going in one shell. Now, atoms. An atom of an element. Again, we've written quite a few times that the number of protons is equal to the number of electrons. So equal numbers of protons and electrons. If we had more, say, negative charge and positive charge, this would be a positive ion. We have equal numbers of protons and neutrons, so this has no particular term. If we have more protons and neutrons, again, there's no term used for that. Here are some symbols. Choose one which is in group 2, and it says a symbol. If we look at the periodic table, you can see we can find calcium in group 2. So it's really important to make sure you are very good at referring to your periodic table a lot of the time. So question 6, where is the number of protons equal to the number of neutrons? Again, if you use your periodic table, you can find the atomic number for each one. And the only one where this is true is this one here. Number of protons is 8. If we do 16 minus 8, gives us the number of neutrons, 8. So it's D. Mass of 1, charge of 0. If we look up at our table back here, mass of 1, charge of 0, you'll find this is a neutron. Now, this one here is why are these isotopes? Again, the definition of isotopes is, and if you got this wrong, I would like you to write this down, atoms of the same element with same number of protons but different number of neutrons. So which one could this be? Same number of electron shells. This is a true statement. Both have a sum of protons. True statement, but also it fits into our definition of what isotopes are. Both have 7 outer shell electrons. Also true, both found in group 7. Also, chlorine 35 has 2 more neutrons than chlorine 35, but that's not the key thing. The key thing is we've got the same number of protons, which is not a metal. If you identify each one, you could either do this by looking up these numbers as in the lower number on the periodic table, or you could also write the electron configurations for each one. You can see these two here are in group 1. So metals are in group 1. This is in group 2. Looking again at the number of electrons in the outer shell. This one here has a full outer shell. This is a noble gas. This is in group 0. Group 0 are non-metals. Here is a table showing mass number of neutrons, and it asks us to say which isotopes are the same element. Now, what we could also do, if they're isotopes, we're looking for things which have the same number of protons. So if you got this wrong, you need to add an extra column here called number of protons. The difference between these two numbers is 17. Here 17, here 19, and here 18. The only two which have the same number of protons are W and X. So W and X are isotopes of the same element. Mass of chlorine is 35.5. What's it relative to? Earlier we gave a definition of relative atomic mass, and it's relative to 1/12 the mass of a carbon-12 atom. What element is this? I find it easier to just go and look at the electrons. So 2, 8, 1, 2, 3, 4, 5, 2, 8, 5. If we look it up in the periodic table, 3 shells of electrons. So we're looking for something in period 3. 5 electrons in the outer shell, so group 5, and from this information we can find it is phosphorus. Complete the sentence. We did a table earlier about masses of particles. Mass of an electron we know is 1/2000, so this number is smaller than the mass of a proton. X has 7 protons, so let's do X. And it has number of protons 7. Y has 8 more protons, so it has 15 protons. As in terms of the number of electrons for each, 7 from this one, 15 from this one. If we wrote the electron arrangement up, this would be 2, 5. This one here, 15, 2, 8, 5. So what can we say? This, and then this has got 1, 2 shells. This has 1, 2, 3 shells worth of electrons. So what's true? Y has more shells than X. That sounds true, so we can tick that one. Let's just go through it. Y has more electrons in its shell. Note they've got the same, so that's false. Y is in a different group. Number of electrons in the shell is equal to group, so that's also false. They're in the same group. Same period. This is in 2 shells, so that means period 2. This is also in period 2, so this is also false. Sorry, I meant period 3. Oxides 1. Now, lots of people probably got this one wrong. Oxides, we need to learn one of the key things was metal oxides are basic. If you got this one wrong, I need you to write the following down. Metal oxides basic, non-metal oxides are acidic. So, metal oxides acidic. This is disagreeing with this first statement, so that is false. Copper, metal, good conductor of electricity. Iron, metal, good conductor of electricity. Sulfur, if you check on the periodic table, you'll find it's a non-metal, conductor and solid. Only metals and one version of carbon is a good conductor of electricity, so that's false. pH is greater than, so pH greater than 7 means the solution is basic / alkaline. I'm getting this out of space here, alkaline. So metal oxides, basic, pH greater than 7, that means greater than, than 7, so that's true. Solution of sulfur dioxide, pH greater than 7. Sulfur we know is a non-metal, and we've only said solutions greater than 7 are basic alkaline, so sulfur dioxide, non-metal. Non-metal oxides are acidic, so we could write the word acidic, and that means pH less than 7 acidic. So we would expect the pH to be less than 7, so false. Noble gases all have 8 electrons in the outer shell. The one exception to this is helium, which has the electron arrangement of 2, so that's also false. Silicon 284. If you look up silicon, you will find it has a number 14 in the bottom left corner. I think the top one's 28. So that means firstly for the first shell 2, second shell 8. Those two numbers add up to 10. So that means 4 electrons in the outer shell. So that is also true. The last one, an atom of nitrogen has 2 what? Shells. And again, if you looked up nitrogen, it's got a 7 here. So that means 2 in the first shell, 1, 2, 3, 4, 5 in the second shell, so 2, 5. 2 shells with what orbiting around. The X's represent electrons. And what is it orbiting? In the centre of the atom, we will find the nucleus. Protons and neutrons. And the nitrogen atom has no charge because it has the same number of something protons and something electrons. Way back when there was a little table describing particles, you said protons were positive and electrons are negative.